Great, so this is the problem called cow training. So in this problem, we have Farmer John. He has N cows training for the upcoming county fair. Each cow has a current skill level, A, and to help his cows prepare, he can give individual training sessions. In each training session, he can increase the skill level of any cow by 1. And he has at most M training sessions, and he doesn't have to use them all. Now for the fair, Farmer John needs to select exactly K cows to perform in the main event. And to ensure that the performance is synchronized, he wants to maximize the bitwise AND of the skills for the K chosen cows. Now, just as a recap, the bitwise AND operation, 1 and 1 equals 1, 1 and 0 equals 0, and 0 and 0 equals 0. So, for example, let's say the sample input test case 1. Farmer John has 4 cows with skill levels 1, 2, 4, and 8, and he can perform 8 training sessions, and he wants to choose 2 cows. Now, I converted these to binary already, and I sorted them from greatest to least. So in this example, Farmer John can give 6 training sessions to cow 3, plus 6, and then he can give 2 training sessions to cow 4. Now, if we added this into the binary number, 8 plus 2 would be 1010, and 6 plus 4 is also 1010. Now, the bitwise AND of these two numbers, 1010 and 1010, is 1010. Now, we want to convert this back into decimal, so this would be equal to 10 in decimal. Okay, so for this problem, it is always optimal to match the prefix, and we want to make the prefix as large as possible. Since our binary representation will be something like B1, B2, B3, all the way to Bn, where each one represents a bit. Now, you will realize that if you make B1 1, that will always be greater than if you make B1 0, since 1000 with 4 bits would always be greater than 0111, which in decimal, we represent this as 8 is greater than 7, and this is always true. If it's impossible to match the first bit, then our new prefix would be 0, 1, and then our new prefix would be 0, 1, and then so on. And we try to match this new prefix, and we want the first occurrence of every 1 to be as early as possible. Yeah, so how do we check if it's possible to have a prefix equal to x? So in this case, in our first case of 8, 4, 2, and 1, we have these are the power levels, or not power levels, the skill levels of the 2 cows with the largest skill level, right? And let's say our x was 1. Then we want to match the prefix of x equals to 1 to both of these numbers. And is this possible? Yes, this is. Our m currently is 8, and we can add 2 to this number over here to make it 1000. Great. And now we've matched these two numbers, are the k required cows, to our prefix of x equals to 1. Now we want to try to match the prefix of 1, 1. So we want to see if we can make the second bit of both of these numbers into 1. And is this possible? This is not possible, since we only have 6 more training sessions left, and it would require 8 training sessions to make both of these have a prefix of 1, 1. And so we give up on this, and our new prefix is 1, 0. It would actually be 1, 0, 1. Now, is it possible to make these both have prefix of 1, 0, 1? It actually is, since we would need, sorry, this would be plus 4. Yeah, sorry, that was my bad. This is plus 4, and so we would have 4 training sessions left. And it is possible to match these, both of these with prefix 1, 0, 1, since we would need exactly 4 more training sessions to add 2 skill levels to both of these cows to make them 1, 0, 1, 0, which is the answer that we found earlier. And we have exactly 0 training sessions left. Yeah, so how do we check if it's possible to have a prefix equal to x? For each element y in the array, which is their power levels, we want to add the smallest possible integer z such that the ones in the x are present in the binary representation of y plus z. So in this case, for, let's say, the power level of 4, and we wanted to match the prefix of x equals 101. Let me just erase this one to avoid confusion. Okay. So we have x equals 101, and we have 4, which is 0, 0, 0, 1, 0, 0. Now, sorry, let me just erase all of these to have more space to work with. All right, so our case 1 is that all the ones in x are already in y. But as we can see here, they are not already matching, right? So our case 2 would be that there is an I such that xi equals to 1 and yi is equal to 0. And we can see that that happens at the first bit over here. And we always want to find the leftmost bit where this happens. Great, and our smallest z will be achieved by letting digits I to n of y plus z correspond to digits I to n of x. And in this case, we would want all of these digits to correspond. So we would convert this. Oh, there is more I need to erase. Okay, great. So we would want all of these bits to correspond. So we would make this 1, 0, 1, 0, right? And to do this, we would have to add 6, or we would have to add 6 training sessions to this cow. And this prefix is valid as long as the sum of all the z's over the k cows that you choose is less than or equal to m. And in the sample case, we can see that we add 2 to the cow with skill level 8 and 6 to the cow with skill level 4 for a total of the sum of z is equal to 8, which is exactly equal to m. Great, and that is how you do the problem.